Someone who understands something better than me, and someone who can share it in a way that I can understand. I would like to introduce everyone to Mitch Robson, who has shown me something. We started discussing this earlier this year. He had this big book. It's big for me to carry. I see him with this big physics book, and he'd ask me things, tell me things, and then he gives me a small scrap of paper. And it says, Theories of Quantum at blogspot.com. I'm like, oh, this is cute. Boy, with this big book, he's showing me a website that he found where he's getting all this information. I underestimated quite a bit.
Okay, this is an introduction to quantum mechanics, and I'm in 5th grade. My name is Mitch Robson. Okay, here's how I became interested in quantum mechanics. 2 years ago, I read something in a book called Schrodinger's Cat that's probably going to take too long to explain right now. So, I can explain it at recess. And so recently I created a blog, and this is the address, which I can usually show at the end. And basically, what quantum mechanics means is there's 2 parts to it. Quantum means a tiny, tiny bit of energy. And it's equal to something multiplied by a number called Planck's constant, which is really small, 6.626 times 10 to the power of negative 34 joules seconds. And you can only have certain amounts of energy. You can't have 1.5 Planck's constant. You can only have 1 Planck's constant, 2. You can't have 1.5, 2.5, 3.25. You can only have whole numbers multiplied by that. So, mechanics is the physics of motion, how things work. So, basically the reason quantum mechanics was invented was because something called Newtonian mechanics, which originated from Isaac Newton, had a couple things wrong with it. Because there were a couple laws, like relativity and locality, that were made after Newtonian mechanics. And this made it not valid anymore. And Newton had 3 laws of motion. One was that if something is sitting still, that it will stay still unless a force is acting on it. Like this table will stay still and the second law of motion says that, well, to explain it in an easier way, if I hit a golf ball, the force of me hitting it equals the mass of the golf ball, how big it is, times how fast it's going. So in that case, the mass is pretty small and the acceleration is pretty big. But if I do the same thing, if I hit with the same force, I hit a truck, then there will be a big mass and a small acceleration, so it all evens out. And the third law of motion says that I can't just press down here and it'll just fall. It also exerts a force on me. I can feel the table pushing on me when I push on the table. So, the good things about quantum mechanics is it does obey things like relativity and locality, and instead of making energy seem continuous, like you can have any amount of energy you want. Like I said, it's discrete, although it doesn't seem discrete because Planck's constant is so small. So you can have 1 times Planck's constant, 2 times Planck's constant. So you can't have any amount of energy you want. And the problems about quantum mechanics is that it can only predict probabilities. It can only predict if it can't say this coin is definitely going to land on heads. It can say there's a 50% chance this coin's going to land on heads. And another problem that you might have to get over is that there's a lot of things we have to abandon from everyday life that we may think is true but isn't. Like, for instance, energy is continuous. We can have any amount of energy we want. Instead, we have to have bits of energy multiplied by the number of Planck's constant, 6.626 times 10 to the power of negative 34 jouleseconds. And so Planck's constant is used in many quantum mechanical equations, and it's very important because it's like if you cut a piece of bread up, Planck's constant is like the knife that cuts the bread. You're supposed to cut each slice a certain amount. You can't 1.5 slices. If you want to make 12 slices out of this amount of bread, 12 equal slices, you can cut one slice bigger than another. You have to have them all equal. So, you can check out my blog at theoriesofquantum.blogspot.com. I'm also free to tutor kids in math. Right now I have a range of 6 to 8 years old. And this is my blog. You can read it. This one actually happens to be about Schrodinger's cat, which is how I first discovered quantum mechanics. And you can take a poll. It's pretty much about how much you can understand it. And there's some information about me right there. And so that's my presentation.
But I want to say, when he gave me that sheet of paper, I thought I was going to a fun website. They send me things all the time, and I got a huge kick out of that, and I encourage it. And then I'm literally reading an article, and I'm like, wow, this is explained well, curious question. And then it peeked up in the corner, Mitch Robinson, 10 years